Good day. Today we will be talking about the Pythagorean Theorem, which is the most widely used theorem in all geometry. It is very old. Dates back to about 500 years before Christ, Athens, Greece, by a mathematician known as Pythagoras. This is why it carries his name. However, there are documentation that proves that even beyond 500 years before Christ, this is all the way back to 800 years before Christ, that there was already use and proofs of this in India. But Pythagoras is the one that published it along with his Pythagoreans in Athens, Greece, and therefore he gets the credit for it. Doesn't it always work that way? There we go. So therefore, you probably already know it. In fact, it is a widely known theorem throughout the world, of course, and even used in The Wizard of Oz. If you remember, there was one of the characters who needed a brain. And so when he finally got the brain from Oz, the first thing that came out of his mouth was the Pythagorean theorem, which basically states that in a right triangle, the sum of the square of the legs is equal to the hypotenuse squared. So there you are. It is a squared plus b squared is equal to c squared. You already know it and have seen it in many other fashions and forms in other classes. And today we're going to be applying it. What is important about the theorem itself is that you remember that c squared is the hypotenuse. That's the guy that goes by himself. As far as the other two, they're called legs, and it doesn't really matter where you place A or B or B or A because you're adding them anyway, right? Okay. I also in class have given you a set of Pythagorean triples for you to memorize. These triples are going to come in very handy when it comes to the SATs and other exams that you will be taking, because you can either spend a few minutes using the Pythagorean theorem or do it real quickly if you know some of the triples. And the main triples that I want you to memorize are the 3, 4, 5 Pythagorean triple, 5, 12, 13, 7, 24, 25, and 8, 15, 17. Once again, I want to remind you that the most important thing here is that you remember that the biggest one is always the hypotenuse. And another side note is that their multiples also work. So why don't I give you all of them? Because there's too many multiples. In other words, if you multiply these all by 2, 6, 8, 10 also works. 9, 12, 15 also works. 10, 24, 26 also works. And so forth and so on, okay? One last bit of information about the theorem itself, and that is that it can also be used to determine whether triangles are right, obtuse, or acute. The Pythagorean theorem only works when it is a right triangle. So obviously, if a squared is equal to b squared, if c squared is equal to a squared plus b squared, that means that this triangle must be a right triangle, because the Pythagorean theorem only works with right triangles. However, if the hypotenuse squared, c squared, is equal to a squared plus b squared, then it is known as an obtuse triangle. You see the greater than. And conversely, if c squared is less than a squared plus b squared, it will be an acute triangle. Okay? So now that you know all the important facts about the Pythagorean theorem, let's do a few of these together and see what I mean about the Pythagorean triples. Take this first one, for example. You can spend a few minutes going over and using the Pythagorean theorem, which I will for you. However, for those of you that catch on, you can figure out that x here is quickly 10. Why, you ask? Well, that's because it is a 3, 4, 5 Pythagorean triple, but yet doubled, 6, 8, 10. And so 6 and 8 are my two legs, and therefore that would be 10, and you'd be done like that. If you don't see it right away, then you have to do the work. 6 squared plus 8 squared is equal to x squared. 36 plus 64 equals x squared. 100 is equal to x squared. And of course, when you take the square root, you get x is equal to 10 anyway. Okay? Let's try this one over here. Well, once again, hopefully you caught on by now that this is a triple. And so keep your triples handy. 7, 24, 25. Again, if I was to call this x, there's my 7, there's my 24 and 25. Yes, this would be 7 and you'd be done like that. If you didn't, then you'd have to write the Pythagorean theorem and say x squared plus 24 squared is equal to 25 squared, and use your handy dandy calculator and do all the math, and yes, you would still get 7. But I'm hoping you catch on to the triples and you use them as widely as often and whenever it is possible, right? Take this example here, and you're going to say, I'm going to look for the triple. Let's see, 4, 6, even if I take divided by 2, 2, 3. Oh, there is no 2, 3. So not everything's going to be a triple, obviously. So therefore, let me go ahead and do it the good old-fashioned way. I'm going to call this here x, and I'm going to say 4 squared plus 6 squared is equal to x squared. Remember that the most important one is always the hypotenuse opposite the right angle, which goes by itself. Obviously, this is 16 plus 36 is equal to x squared. When you add both of these, you're going to end up with 52 is equal to x squared. When you take the square root, you got 52. Now, if it was a word problem, I would be expecting you to give me this to the nearest tenth using your calculator. But because it's not, I am expecting you to simplify this. In other words, I need a perfect square number, a magical number that goes into 52. And let's see, I think it's 4. 4 times what? 4 times 13. Such that the square root of 4 becomes 2. Radical 13 cannot be simplified. And that's what I would be expecting you to give me, okay? Let's try one more, and I'll try to make this one a little bit more of a challenge because I'm going to give you a square root. So obviously with square roots, there is no triple for you to look into. So let me go ahead and get started. I'm going to call the second leg x. And so I'm going to say x squared plus 2 squared is equal to 2 radical 3. And I'm going to use the parentheses to make it easier, okay? This is x squared plus 4 is equal to. Now, when you square this group here, made up of a free number and a jailed number, in other words, you're going to square both pieces. 2 squared becomes 4, and radical 3 squared becomes 3, which is 12. And therefore, when you take away 4, you get x squared is equal to 8. And yet again, don't forget to simplify and show me. This is 4 times 2. And then when you take the square root of 4, you get x is equal to 2 square root of 2. And that's the Pythagorean theorem in a nutshell. Okay, now you can go practice with your assignment.